What's up, peers, and welcome to the World Crypto Network. Here back for the Understanding Bitcoin. No, not the Understanding Bitcoin. That was sometime else. Here's the Breaking Bitcoin conference in Amsterdam. We're joined here by Ruben, who's working on some awesome stuff, including the Bitcoin Soul meetup and the Unhashed podcast, and now also on something very interesting in the research side of Bitcoin Core, which is Statechains. And so we're going to talk about all this today. Ruben, how are you doing?
I'm doing fine, thank you.
How do you like the conference so far?
It's pretty good. There's a lot of good content. Personally, I like the networking, so meeting all the people, hanging out with the devs. There was the core dev meeting also before the conference, which is actually the main reason why I was here. And so I'm presenting about Statechains at the conference, but that was not planned. So on Friday, basically they were asking like, hey, somebody dropped out, so can somebody present? And I had presented about Statechains earlier in October at Scaling Bitcoin, and so I was able to do it here again. And the slides are slightly similar, but there's some updates, and that's kind of what I wanted to talk about. Yeah.
Okay, very interesting. So Statechains are quite novel, I would say, approach of somehow combining sidechains with channels in a Lightning network, which is very, very interesting. So maybe let's start with those two basics. Mm-hmm. How would you say, what is a Lightning network and how do these channels operate?
Lightning network or just Lightning network in general, or what is your question?
Like the basics of Lightning network, especially with the channels, and then just as the basics for what you need then to later elaborate on Statechains.
Okay, well, I mean, I guess the main thing I should mention is that the Statechains idea utilizes L2. Mm-hmm. So that's a layer 2, it's a variant of what we're doing today with Lightning. Right? With Lightning currently what you have is a revocation where if we change we have a channel together and we change the amount of Bitcoins that are inside, we have to kind of give each other a revocation key where if the old state ever gets onto the blockchain, we can punish each other. And this is replaced with basically a state number in L2, where if you publish an old state, you can now publish a newer state. And that is also kind of the mechanism that allows things like Lightning channel factories, and in this case also Statechains, because that is kind of a multi-party channel where it kind of looks like a 2 of 2, but it's actually a 2. Well, it's a bunch of people. It's an infinitely grown group of people. It's kind of hard, weird to think about, but yeah. So that's Lightning, and I mean, should I talk about like how that integrates into Statechains?
Yes.
Yeah. So with Statechains, the basic idea, and we kind of ran through it before, but so the idea is that you have a single person or a server that can actually be a federation or a group of people. So for simplicity, just think of it as a single person. Let's say I'm the Statechain entity or the server, and but in actuality, I'm there's like a bunch of companies that are doing this together. It's a 5 out of 10 or 8 out of 12 multi-sig, something along those lines. And then the second key is yours. So what you do is you lock up money together with me. So it's me and it's you. And in order to make sure that you can actually get the money back once you send it to this address, I give you a L2 transaction, where that means that you can always send this L2 transaction to the blockchain and get the money back. So once you have this transaction, you send maybe 1 Bitcoin to this 2 of 2 channel, and since you can always get it back, you're fine. And now we want to transfer this money. So because that's the idea. The Statechains idea is, how do we transfer a UTXO, the ownership of a UTXO, from one person to another person? So the way that works is you give literally the private key that you locked up your money. You locked up your money with me. That private key, you hand it over to another party. Mm-hmm. Then you go to me and you ask, hey, can you sign this message for me? And what I'm signing is an L2 update transaction that now assigns the money to this person. And on top of that, you tell me, okay, now the next time somebody asks you for a signature, only listen to this guy. Mm-hmm. So on my side, all I do is sign a message from a person, and then listen to the next person. And then that person gives me a message, I sign it, and then I listen to the next person. Mm-hmm. That person gives me a message, I sign it, and I give it to the next person.
Mm-hmm. And the message is always authenticated by the same transitory private key.
The message, well, it has my key and it has the transitory key, which is the key that you pass on from user to user to user. And the point of that is that there is this kind of barrier between you guys, right, all the people that the money went to, and me. So I am not custodial. I don't control the money. If I wanted to cheat, I would require one of you to participate, to cooperate with me. And my promise, so there's still some trust, right? My promise is that I only listen to the last person in the chain. And if I ever break that promise, there would be evidence of cheating, basically, because then I signed, maybe I listened to you twice, right? So you asked me, hey, transfer the money to this guy, and then it's like, hey, I changed my mind, transfer it to this guy. So now I gave out 2 signatures, and you can prove it to the world, and it's like, okay, well, the state chain entity or the server or me cheated, therefore, this whole thing kind of falls apart. So there is still, a very clear trust element, right? You're trusting the server, but in this case, the federation. So it's roughly a similar trust model to something like federated sidechains.
Okay, and so then in the case where someone is stealing, though, can I not prove with the L2 that I have a more recent state that I can then publish on the time chain?
So, well, the stealing. So the stealing is, so there's one more. Well, okay. So the thing we can do, right? We passed on the money to the next person, and they have a higher state in the L2 channel. Now you come to me, say like, hey, let's take the money back, right? So we just sign another transaction with an even higher state. So now you can take the money from the guy, right? So you can definitely get the money, but it requires the federation to not do what it's promising, and so that's really the same security model as something like Liquid. But I think the nice thing is there are 2 things. So one thing I haven't mentioned yet is that these are all blind signatures. So that's important because, so the first thing we've established is you guys have a key, I have a key, I'm not custodial. Second thing is, I don't actually have to know what I'm signing, right? You just tell me like, hey, sign this message. I sign it, and now I'm listening to this next person. You told me to listen to the next person. I sign a message for them. If I don't know what I'm signing, that's fine. I can just sign all these messages, and when you transfer the money, these people are the ones that care what message it is, right? Because they need to check, well, didn't you, if your L2 state is higher than it's supposed to be, then they are going to be screwed. So they all unblind the messages, and they check whether or not what I signed is in line with the, that they are actually the ones receiving the money. And if that's not the case, they don't accept the payment.
Yeah. Okay, that is interesting. Yeah, and so you always say that when one person makes the signature, then he also says, listen to this next person.
Yes.
How is that enforced? Do you give a public key and the signature?
So the person, so in this case, like if you locked up some money with me, that means that you get one signature from me, and at that moment you also give me another key that is the next person that's going to request a signature from me. And that next person is going to be the person you're transferring the money to. It could also be you if you want. You could send, you could give me another key that's actually you. I don't know, and it doesn't really matter to me. But one thing that we haven't really gone through yet is that we're sending full amounts, right? So we're transferring the entire Bitcoin. Not you can't really ask me to. Well, it's hard to split up the amounts, basically, right? So right now what we're talking about is transferring the full Bitcoin from one person to another person.
Yeah, so right, because it's the entire UTXO, and you hand over the private key of this UTXO.
Yeah.
Right? So you cannot really split up the UTXO. That would require another on-chain transaction, which will kind of defeat the purpose of what we're trying to achieve here. But these are similar trade-offs in many regards to Chalmian eCash or to other digital bearer certificates, in the sense that you rely on the signature of the central server and then also telling him this is the public key of the person who now has the coin, especially when we use the blind signature element.
So it really is kind of like turning a UTXO into a Chalmian token. I forgot who gave me that analogy, but I think it's a good one. So yeah, you can think of it like that, where the UTXO itself is the token, and you're transferring it from user to user. And so there are a couple of clear downsides that we should probably go through, right? So the first one is, well, what if you want to send less? if you want to send less money, there are two options. So the first option is we can utilize adapter signatures. This is kind of a way to atomically to kind of do two transactions at the same time. So if somebody else has 2 times half a Bitcoin and you have 1 Bitcoin on the state chain, you can swap these. You can trade these. So you have now 2 times half a Bitcoin and this other person that has 1 Bitcoin. And now you can give this half a Bitcoin to somebody. So that's one way of doing it, right? You could think of it as, giving somebody a $10 bill and getting a $5 bill back or something, right? So this is possible, but even this is restricted, especially when you think about like maybe fees, if they go up. Realistically, what's the smallest UTXO that you can redeem on chain? If you have to pay $1 for fees, well, then maybe the maximum or the minimum you want in a UTXO is $10, right? Because, well, you're gonna have to pay $1 to get the $10 out. So therefore, there's kind of a limitation there. So this doesn't really solve the full problem. And the full problem is solved with Lightning. And basically, what we do is on the state chain, you can open up a Lightning channel. And the way that works is that because for me, it doesn't really matter who I'm signing on behalf of, right? So you're transferring the money from one person to another person. I don't even know if it's money, right? I'm just blindly signing messages. And the second key could be a 2 of 2. Mm-hmm. And if it's a 2 of 2, and what I signed was an update transaction, L2 update transaction, they can then utilize that off-chain transaction to create yet another transaction on which they split up the amounts. Mm-hmm. So they're opening up a Lightning channel on top of a state chain.
Yeah, this is a really fascinating approach, right? Because so as we said, this is kind of Chaumian eCash, but with a UTXO as the token. And with this UTXO, we can transfer the entire UTXO. Mm-hmm. But then usually, like the naive implementation is one single signature and public key for each of these like UTXO transfers. But of course, with Schnorr key aggregation, we can get, for example, the 2 of 2 multisig, and then use this as one transfer of the UTXO. And all of a sudden, this UTXO is no longer locked up by the single signature, but by the 2 of 2 multi-signature and the HLCs or adapter signatures for the other time locks that we need for Lightning Network. So all of a sudden, we transfer one UTXO, and it's no longer a single sig, but it's a multi-sig with time locks, a Lightning channel opening. And then we've just done a eCash transfer of a UTXO to open a payment channel.
That is correct. Yeah. So it's an instant open of a channel with that's really cool, right? But with the trust assumption that the federation is reliable, right? So if the federation is not reliable, that is kind of the key ingredient here. So there is some trust involved, but we're minimizing the trust in 2 ways, right? So we have this key separation, and I would argue that is mainly in order to prevent something like, let's say a government comes to me and says like, hey, you're facilitating illegal transfer of money, then in that case, I can't really do anything about it. If they say like, hey, confiscate this guy's coins. It's like, well, I only have one of the 2 keys, so what am I going to do, right? I can't help them. And then the second thing is, if I stop functioning, right? If I stop helping you, if I disappear, if I lose my keys, you always have this off-chain transaction that you can send to the Bitcoin blockchain, and then you got your money back too. So there's not a whole lot that can be done. And then on top of that, even if some government entity comes to me and says like, well, you're a money transmitter, right? You're facilitating the transfer of money to people that might do something bad or something. Well, I don't even know I'm doing that, right? So I'm just signing these blind messages. So you can make that claim, but it's kind of being one analogy or one way of thinking of it is you're outsourcing the decision making to the users. I'm not the one deciding what I'm doing, what I'm signing, and what kind of Bitcoin transactions are happening. Like that's all up to you guys, and I'm just facilitating the process by just signing something blindly. And I think that is very interesting from a legal perspective, or kind of like thinking about like, well, what is even a definition of transferring money, right? Signing a signature on something, is that money transfer? Right? Well, now it is. So
yeah, it's Bitcoin is pretty crazy in that regard. Absolutely. Right. So okay, so for every of these 2 transactions, we need the corporation of the state or of the federation, let's call it, of the server.
Yeah.
But then if we open a Lightning Network channel with such a shift or transfer of the UTXO, then can we do updates to this payment channel, to this individual payment channel, just with Alice and Bob and without the server?
Yeah, you can do both. You could do it with the server, you can do it without the server. Doing it with the server has the benefit of the worst case getting a little bit smaller. So if you update your Lightning channel together with the server, or with the federation, let's call it, maybe that's a better analogy, then your transaction, it's really just the same as an L2 transaction. So if if we were to open an L2 a channel on Bitcoin, it's the same number of transactions as the state chain Lightning channel. So the worst case is the same amount of transactions that go to the Bitcoin blockchain. If cooperation breaks down, you send everything to the blockchain, same size.
Yeah. Okay. Yeah. That makes sense. Yeah. And with this, it really is fascinating because not just do we remove information from the blockchain or from the parent-based chain, where we have where it's actually a really precious commodity, and we combine and we batch transactions. Not just with the shift of UTXOs by sharing the public key with the next person, or the private key, but then also after each eCash swap, so to say, of the UTXO has happened, we still then do further consolidation and further batching and further efficiencies with a Lightning network on top. So that's layers upon layers upon layers.
Yeah, I mean, you can do weird things. You could theoretically, because the federation doesn't know what it's signing, right? So you could actually have the federation wrap around itself. So you could have two keys be the federation, for instance. So you need the federation to sign twice to move the money. It makes no sense. It's not useful, but because the server is just dumb, right? It doesn't know anything, and which is great. From a scaling perspective, it's just this. It's it's the analogy of the blockchain. In Bitcoin, the blockchain has to be simple, and the more work you offload to the users, the more it scales because everybody's got to verify the blockchain, right? It's kind of like that. So yeah, that's very interesting. So there are a few things that we should still get into. So the first thing is that we haven't really mentioned, which is coin swap. So let's say you have one Bitcoin locked up with the state chain, and a bunch of people have that. Well, you can swap all these simultaneously. So now it's like an off-chain coin join essentially, where you suddenly have somebody else's UTXO, and on the Bitcoin blockchain you don't see any evidence, and so yeah, it's a very clean way of doing that. I haven't fully thought through the privacy implications, but it seems pretty good, at least at first sight.
Yes, it seems very, very good because we exchange ownership of a UTXO. I mean, with an atomic swap on-chain, with a coin swap on-chain, there are two on-chain transactions, right? A one input, one output, single signature transaction block 100, and one in block 200. And Alice swaps her input from transaction 1 with the output of transaction 2, and Bob swaps his input of transaction 1 with the output of transaction 2. No, transaction 2. 1. Well, they swap. But that still requires two on-chain transactions. Yeah. And now with state chains, we can swap a UTXO on-chain that looks simply with a public key, thanks to Schnorr key aggregation. And all of a sudden, we swap ownership without ever touching the chain.
Correct. Yeah.
And we do that instantly, very cheaply, all the time.
Yeah.
And you don't know it's happening. And even the server doesn't know it's happening.
Even the server doesn't know it's happening, which is the beauty of it. Yeah. So there's a lot going on there in that sense. Yeah, it's pretty cool, right? But there are two things that should be mentioned. So the first is we need Schnorr signatures for this. Second, which is slightly harder, which is we need it's now called SIG hash any prev out. It used to be called SIG hash no input. That is the kind of the building block that we need in order to do something like L2. So once we have that, theoretically, this state chains idea can be built. That might still take a while longer before we actually get that soft forked into Bitcoin.
2 weeks. 2 weeks.
So at the CoreDev meeting, there was a lot of talk about how to do SIG hash any prev out, and there are still a lot of design considerations. The main concern being that there is this kind of replayability concern where if you reuse a key, you could take a transaction that has occurred and you could use it again for another transaction. So if somebody sends one Bitcoin to your key and then you use SIG hash any prev out, to spend it, and then somebody accidentally, stupidly sends another Bitcoin to that same key. Now that transaction can be reused, and that was not your intention. So that is one of these vulnerabilities that you could argue that if the users are careful, it's fine and nothing will happen, and it's kind of like a user thing that they like. If they mess up, it's like kind of like, oh, if you send your coins to a burn adder as well, then your coins are gone. But at the same time, I think it's also important to make sure that kind of damage is as limited as possible.
Yeah. Okay. That is very true. Yeah. So I mean, updates always take a lot of time, a lot of attention. Maybe one additional thing that we didn't yet really mention is that it's a drop-in replacement for one part of the stack of the Lightning Network, right? Because when you have this UTXO in the state chain and you swap it, and eventually with one of these swaps you open the Lightning Network channel or L2 channel, then this L2 channel can do individual payment channel updates as we discussed earlier, but also it can route payments throughout the Lightning Network.
Correct. Yeah.
And each individual doesn't really need to know what the base layer thing for this UTXO is.
No. Yeah, I would argue that that's a feature of Lightning. You could use Liquid in the same way. And you could theoretically even open a Lightning channel with just IOUs, so this is completely theoretical and not practical, but we could say like, hey, we trust each other up to 1 Bitcoin, so let's just open a channel. And now we have this channel that's not actually on the Bitcoin blockchain, and we just update it as if it was. And because we never go to the Bitcoin blockchain, so to speak, because there is no money to go back to, that's our Lightning. Right? And then we just trust at the end of the day, if we ever want to close this channel, this is like, okay, now we'll go on chain and send me these Bitcoins. Yeah. Right? So so Bitcoin Lightning is kind of chain agnostic in that regard. And that's also why it works like on other chains. Oh yeah, so that's also the same with Statechains. It's also blockchain agnostic. So you could have like a Litecoin state chain, and you could have a Bitcoin state chain, and you could swap them. And now you're doing something akin to like decentralized trading, right? So it's like a DEX or something. So that's even possible. Did you get that?
Yeah, that would be possible. Yeah, you could that's the cool thing with coin swaps. They work both with the same coin as well with other coins if they have the same cryptographic primitives, which most of them do. So
yeah, I mean here it's even the cryptographic primitive. Oh yeah. I mean there's still the requirements for any chain so if you want to add Litecoin to state chains, the Litecoin needs to support Schnorr, and Lightning needs to support something akin to L2.
Yeah, that is true. Yeah, so basically.
So then
very interesting.
Yeah, so the final thing that I guess we haven't talked about yet is that there's a lot of talk with the Lightning Network about splicing in, splicing out, adding liquidity to your channel, right? So let's say we have a channel that's about to run out. Can we add some coins to it, or can we push it back? So that can all occur off-chain now too. Whereas with the splicing in, splicing out, it requires some kind of on-chain transaction. You can do that off-chain. So here would be an example. Let's say, what would be a good example? Yeah. So let's say we have a channel where we both have half a Bitcoin on a state chain, and we want to close it for some reason. So maybe you have half a Bitcoin on a state chain somewhere else. You give me that half a Bitcoin, and we update the channel where that half a Bitcoin that was mine goes to you. So on the Lightning channel, the money all goes to you, and on the state chain, I receive your half a Bitcoin. Now you have 1 Bitcoin on the state chain. I have half a Bitcoin on the state chain. So it's a Lightning update plus a state chain's update simultaneously.
Oh yeah, that makes sense as well, right? Yeah. And you could maybe also do splicing with atomic swaps. That if you have a Lightning channel of 0.5 and you have a non-Lightning channel with 0.5, and someone has just regular state chain UTXO with 1, then you swap the coins and you update the state chain with a new 1 that is then a channel opening.
Yeah. I mean, you need to do this all atomically, because if there's no if you're not utilizing adapter signatures or something along those lines, there is potential for cheating where half the trade goes through, right? So you go from you get my half a Bitcoin, I don't get your half a Bitcoin. So this is all has to happen atomically. And in fact, it even supports things like Lightning channel factories. And this is I talked to Christian Decker about this, and actually it was Anthony Towns who suggested it to me early in the beginning. But what you can do is, with a Lightning Channel Factory, kind of the problem is that you have this set group of people, right? So, if we have like a group of 5 people that we all want to collaborate together and send Bitcoin transactions to each other, we open a channel on the Bitcoin blockchain. And now from that point, we can all create these Lightning channels from the channel factory. Yeah. But the issue is that now, in order to change any of these channels, all 5 of us need to agree. And if somebody wants to leave or somebody else wants to enter, you have to do another on-chain transaction. And now you can take it all off-chain, right? So you can just add new members to the factory. You can take up members, and you can do it all off-chain through Statechains.
Yeah, that is fantastic.
Yeah.
And also one point that goes hand in hand with this, and that blew my mind, is that you can do onboarding onto Lightning without ever touching the parent base chain. Yeah. That is quite insane. Yeah. Because if you have the UTXO in a state chain and it's already a couple hops advanced, so Alice has the state chain and she wants to give it to Bob. Bob is a complete no coiner or future coiner, where he then he generates a public key, a private key, and that is completely off-chain new private key pair, new thing, and he gives the public key to Alice, who then puts this in the message to the coordinator or to the factory. No, not factory. To the
Federation.
Federation, yeah. Exactly. And then they just include Bob's public key into that message and only listen for his signature next. And now Bob has the tip of the state chain, and that can be a Lightning Network opening.
Right. Yeah.
It's crazy because now we literally can onboard unlimited amounts of people on Lightning because we don't even have to do on-chain transactions, other than, of course, opening and closing the chain state.
Yeah, and again, I want to re-emphasize there is this trust assumption, right? Like Lightning is superior in terms of trustlessness. Like with Lightning, you don't have to trust any party, and the only assumption you have in Lightning is pay attention to the blockchain, respond if there's some data, right? If there's an uncooperative close, you have to go and you have to react to it. That's the case with Statechains too. You still have to react, right? If somebody sends an old state, you got to also react to it. But with this, there is still the possibility that, a prior user comes to you and says like, hey, let's screw over this guy. So the worst case scenario would be this, right? The worst case scenario would be I run the federation and I help a bunch of people, and then I go to a bunch of prior users and I say like, hey, if you give me the old key, we'll cut a deal. I'll give you a little bit of money or something, and then I go and I take the money from all these people that I got the transitory key from. So that would be theoretically possible. A little bit difficult to do maybe in practice, but it's entirely possible. So there's still this trust element.
And because you literally communicate the transitory key to a bunch of different people, a lot of them have that. And only if one person rats out and goes to the federation to bring that private key. Yeah. So yeah, that is true. That really is a big part because a lot of people have their private key.
Yeah, so the way I look at that is that it really is federated sidechains in terms of security. Right? With federated sidechains, you give your money to the federation, and they control it. And because it's a diverse group of people, you trust that that's going to be okay. So the two key differences are the federation here doesn't know what they're doing. Right? They're completely blind. Second is they are separated from, that's more of a legal thing, right? From the perspective of somebody comes to me and now I have to go and figure out, now I have to get the transitory key. Well, that's impossible, right? So if anybody asks, like if government comes to me and asks that, well, I can't cooperate. And the third thing is if I disappear, then the money is safe because you have a transaction that you can send to the blockchain. So those are kind of the key differences compared to federated sidechains.
Very true, and I'm curious if we can maybe tweak this a little bit to have a new private key as a transitory key for each hop. Somehow, maybe even with adapter stuff, I don't know,
no,
maybe doesn't, okay. No. Maybe some magic in the background. And
no, it's fairly impossible, yeah. Well, Satoshi came up with something that we hadn't thought of too, so maybe there is something, but now it seems unlikely.
Okay. Well, maybe there's some magic that we can do. Yeah. We'll figure it out. But already,
I do hope I'll get more feedback, and maybe there are some other things that are left that can be added to it. There's already been there's this one idea of like transferring the transitory key with a hardware security module.
Oh,
So-
open dimes.
Yeah, so that was one suggestion that I don't think that works. I mean, Jimmy Song mentioned that to me, and yeah, I still have to think it through. But like, I mean, the original idea was to transfer the hard. So there's something called T-chain. I don't know if you've heard of that, but the idea is that you have this hardware security module, and you have one. And they communicate with each other, and they just pass on a private key. So you could use that kind of thing for a transitory key. So yeah, what Jimmy Song suggested was that, well, maybe you can use an open dime, and you just give it to the person, and you use that to sign like that's the transitory key. So it doesn't go out, but it can sign these update transactions.
Well, but as soon
Yeah.
as you break the open dime and you use the private key to do the signature.
Well, the idea
That's
would be that
probably
it does never comes out. So you cannot take the private key out,
Okay.
and
So kind of like a Yubikey. It's just you put the private key in there and you can never extract it.
you
can
can
only just
sign
sign
with it, but you cannot get the key out.
Yeah, okay.
Yeah.
Okay.
But I mean, I don't think that fully works because you can still get it to sign, whatever you want. You can make it sign twice, so you can't really prevent that unless maybe if you also have states on the hardware security module, but that's very difficult to enforce. Generally, that's not really something you want.
That is. Well, in 2 weeks we'll have it figured out. Pretty sure.
Yeah, I don't think it's 2 weeks, but we'll see. And to clarify, this really is. Careful. Yeah. This really is like at the level of maybe the lightning paper coming out and nothing's been built. And I'm not a professional developer either, so right now it's just kind of the idea phase and kind of like figuring out exactly how it all is supposed to work. And then we get a couple of soft forks, and then maybe by then there are a couple of people that are willing to implement it. But yeah, it's still early days.
Yeah. Okay. So get building. Try to break it, then fix it. That's kind of the theme of this conference. So yeah, maybe then to close out. Do you think we will break Bitcoin here at this event?
Well, we're trying real hard to break it, but I don't think we'll succeed. We're not quite that good, unfortunately. Now.
That's a shame.
I think it's good. What I would say is breaking things is a good way of making sure figuring out what the weaknesses are and focusing on fixing them, right? So I think it's more of that design mentality of looking at, well, how can this break, with the implication of, well, how can we make it stronger?
Mm-hmm. Yeah, exactly. So perfect, Ruben. Thank you very much for all the work you do. Thanks for all the onboarding and so. Thanks for, of course, sharing all this knowledge on the Unhashed podcast, which is quite good.
Yeah, listen to it.
And then, also thanks for all the contributions to Bitcoin Core and to all.
Again, I'm not doing the development, so I wouldn't take credit for that, but sure.
Well, yeah, but like all the research and everything that all comes together in this great project. So thank you very much.
Yeah.
And let's see you around, hopefully soon then when we talk about the implementation of Statechains.
All right. Well, yeah. We'll see. Yeah.
Okay,
Cool.
Piers, thank you very much for joining us and see you on the next show. Bye-bye.